again, you've already kind of hinted at the numbers. You think what, maybe around 600 on the engine, and then get to 1,000, close to 1,000 with the nitrous spray.
Yeah, absolutely. Shouldn't be a problem at all.
Look at he says it's so confident. I love it, man. This is getting good. Welcome to Engine Room TV. I'm John Hammer, and this is our second episode as we follow along in the build of a 1,000 horsepower small block Ford that you get to win. Now, on today's show, we're going to talk about cylinder heads. We're going to talk about intake manifolds, and Doug's stopping by to hint at some of the trade secrets that puts prestige at the top of the engine game. Doug, you're getting to be quite the video star now.
Oh God, I enjoy doing them.
Well, you've got so much knowledge, man, and that's what's really important. And of course, here now we're into episode 2 of Engine Room TV. But before we get going into what we want to talk about today, can you give us a recap about what we talked about maybe in in episode 1, kind of that foundation of building this nitrous engine?
Just as a basic recap for anybody that maybe didn't see it the last episode, is we partnered with World Products on the block, being our good foundation. It's packed with a ton of features, one of which is the billet main caps. This particular block actually uses a 6-bolt per cylinder configuration or pattern. Although we're not using that on this particular combination, that's a great feature that block has. Of course, partnered with Eagle on the crank and rods, and then DSS on the pistons. And I'll kind of highlight on the piston again, a 2618, but some of the features it has that come standard in their FX3 is a lateral gas port and the heavy wall pin we talked about. So that's kind of nice. It's off the shelf. It comes with those. We don't have to upgrade to that stuff. So, but like I mentioned, we kind of forgot the piston ring itself, which is very, very important. So it circles back to kind of one of the things I had mentioned about piston material. So is a nitrous motor, there's certain criteria that need to be met. So the piston material being a 4032 or a 2618. So in this case, we want a 2618. Then really it comes to the piston ring gap. So as we increase cylinder pressure in the motor, the gap is going to get tighter. So obviously when we build and design the combination, the gap has to be opened up. The last thing we want is the 2 ring gaps butting. And how much do we gap it? There's going to be a lot of variables in saying what is going to be the proper gap. A lot of it's going to be to do with how much nitrous are we spraying.
So the idea here is that you've got to get it matched, and you're doing it specifically for this engine. There's not just one generic, ooh, I want to set it to this number type thing, right?
Right. So, I mean, if a guy had a range of, say, well, I might spray 150, we all know we always are going to want more later. So if he gives you a range from 150 to 300 shot, we're going to gap it for a 300. So that way, if he does grow with the combination, sure, the gap's a little big for a 150 shot, but as we grow with it and we get a little bit more confident and spray a little more and a little more, we're not going to run into an issue down the road. Getting into completing it as a long block, we partnered with some other companies such as Comp Cams. They provide us the camshaft and the solid roller lifters that we're using in this. And so, when we talk about nitrous motors, there's going to be, we'll call it nitrous specific camshafts. But a lot of that stuff is changing. As you probably see, the technology and everything from cylinder head design to the air pump itself, piston designs, lots has changed. So what we used to do, say, 20 years ago is not what we typically do today. So this camshaft is spec'd more specifically directed towards nitrous with some small changes. So
is that in lifts and durations, or is it in the material it's made out of?
No, it's more about the camshaft spec. So some of the old theories is obviously focusing on the exhaust side. So if we're packing more nitrous or more air and more fuel into that cylinder, then we've got to focus on that exhaust side to get it out. So in a camshaft profile, you might look at a little bit more exhaust duration. You might open the exhaust valve a little bit sooner. But again, you know, we don't want to get into too much detail there because there's so many variables. If you're talking about a light street car to a full-on race car, it can be totally different. Nowadays, what we're seeing is what really works well in a naturally aspirated combination with some minor tweaks is really works well in a nitrous application as well.
I see you've got another engine on a stand right next to it. Looks like that's pretty fully dressed up there. Can you kind of show us the difference between the two?
Well, so that one was just a display. We've got, you had mentioned, you know, our target's 1,000 horsepower on this particular application. That will be not a problem at all. We just ran one this morning that a 300 shot on a 600 horse motor, made 933 first hit. And so we were really happy with that. We just have so many in process right now. It just seems like there's a plethora of nitrous engines. It's pretty cool. That was just another one. That one's actually also going to be like a 250 to 300 shot. It's a plate kit underneath the carburetor. Again, pretty generic, pretty basic. There's lots of different nitrous technologies, whether it's a plate design to a fogger kit. So that was just another example of what's out there and what we can offer. So.
Sounds good. Well, for the engine that we're putting together, and that, by the way, if you're just tuning into Engine Room TV, maybe you haven't heard this yet, but we're actually going to give this engine away. The stuff that's going on ours is being picked out specifically, and that's one of the things that that Doug and the guys at Prestige Motorsports were really adamant about, was to make sure that not only do we show the parts that they're putting in there, but the reasons why. And that's really, I mean, kudos to you. And most, you know, engine builders are real secretive about what they're putting in there and why, trade secrets really. But that's something that you're really proud of, right? Is the fact that you want to make sure that the right information is getting out there.
You know, if we're selling a short block, or we have a listing for a short block or a long block, and a guy sees that it's all forged, they just assume immediately, well, and I can put nitrous on it. So part of this is, there is some trade secrets. There's some things that we will do that we may not let the average public know, but most of it is just the commonplace of the pistons, the ring gaps, you know, if we're doing head studs or head bolts, the type of head gaskets, all the things, so a guy understands, is it nitrous friendly or is it not? You can get away with nitrous if you're using very small amounts on just a general application, but when we're starting to get into the 300 and 400 shot where the nitrous and above, all of this stuff becomes more critical.
All right, let's move on to the top part of the engine. I know that you've got you got heads here. We've got to get the correct work done on those things, and you've got to do some of your magic on those heads to make them work, right?
So when it comes into cylinder heads, we're looking at certain things like the deck thickness. So that's basically saying that how thick the cylinder head deck is, so we can get good clamp load on our fasteners to keep that thing sealed up. So AFR does a really good job of 750 thousandths plus deck surface, so it's very rigid. You don't get the head moving around. And then, as I said, we changed to an Inconel exhaust valve. Now, Inconel is actually a trademark named by a specific company. Really, it's just a family of super alloys, and those super alloys are more resistant to higher temperatures, or they will work in sustained temperature environments. So the Inconel or Super Duty exhaust valve was one upgrade we made, and of course, we sourced a spring to accommodate the cam profile that we're using for this.
You talk about how the head moves around on there, and it seems to me and I'm not the world's biggest engine guy, right? And it's like, it seems like it's so firmly bolted onto that block. So when you talk about it's moving around, you make it sound like things really move around quite a lot. In reality, it's a very small amount, but the very small amount can make a real difference, right?
Absolutely. So we actually have another one on the bench for another build that's going to get actually quite a bit more nitrous than we're running on this combination. And this is the same head. It's an AFR. So what you'll see is we've fire ringed it. So again, when we're talking about clamping the head down, so you can imagine we have, you know, on this particular cylinder, these two bolts, there's nothing in the middle. So if we had a 6-bolt per cylinder head and block, then basically we'd have a bolt here and another bolt back here. And that's going to really, really seal that entire chamber. When we're dealing with a small block Ford on a standard pattern like this, if we didn't have the thickness in the deck here, then in between here, it basically starts to, yes, move around. It is a small amount, but a small amount does make a big difference, as you said. So
we've already said that, the estimated retail price on this engine, when we give it away, it's going to be worth, just shy of $21,000. How many hours, man hours, do you have going into one of these engines? I mean, here's what I'm getting at. If there's a guy watching right now and goes, man, I can do that myself in the garage, man.
Yeah, so it varies a lot, but generally speaking, this is a pretty conventional build. So we say anywhere in the 35 to 40 hour mark. Where you can soak up an absolute immense amount of time is in the dyno room. If you're doing testing and R&D, just even when we get to showing you the top end of this, with all the Holley products and the EFI, it's relatively easy stuff to work with, but spending the time to wire it correctly, terminate everything correctly, that's where the man hours really start to add up. Yeah, so we'll take an opportunity just to show you the Holley high ram manifold that we're using here before we get it bolted down. So one of the things that we do have to do to these particular manifolds is do a port match. What they do at the factory is actually keep that port exit pretty small. And the reason is that way we can match it up to just about any cylinder head. The AFR obviously has a little bit bigger port on the intake runner side of the head, so we're matching that to the manifold. But if you had a cylinder head that had a raised intake type of configuration, they just leave lots of meat, so we can match it up perfectly. So we already did a port match. Once again, that goes into the labor hours that it takes to do these engines. So definitely to get optimum performance, we want to fully port match it. So we'll get this thing glued on. We'll get the spray up on top, and we'll be on the dyno and definitely show you, the results that it made, kind of how we got there. We'll talk a bit about the nitrous control, progressive control, and how we've got it wired. So we'll get in a little bit of more detail on that side of things too.
Well, really looking forward to it. Obviously, you've partnered up with the right folks. You're putting this thing together with the right people, doing the right work with the right stuff. And come next episode, we should be able to see some pretty stout numbers in that dyno room. Now, I've been there before. I know what it's like. I've seen stuff go, and it is really, really impressive, man. So really looking forward to getting ahead and seeing what you guys are able to do. Again, you've already kind of hinted at the numbers. You think, maybe around 600 on the engine, and then get to 1,000, close to 1,000 with the nitrous spray.
Yeah, absolutely. Shouldn't be a problem at all.
Look at he says it's so confident. I love it, man. All right, listen, you guys, I'm glad you've been watching the show, and we can't wait to get Doug and the guys into the dyno room. That's the next episode of Engine Room TV. Looking forward to it. Doug, thanks for your time. Thanks to all the guys in the shop right there. We can't wait to see you again.
Yes, sir. Thank you.